Hello, so are you struggling with quadratic equations? Well, don't worry, you're not alone. In this video, we'll go through the four main methods of solving a quadratic equation. We'll begin with an introduction to what quadratic equations actually are. We'll then move on to multiplying out brackets, the FOIL method, then solving with graphs, calculating graphs, plotting the coordinates, and drawing the parabola, which is the U shape that a quadratic equation forms. We move on to factorising, or you might know of it as factoring, depending where you are in the world. That's just where we pop the quadratic into double brackets and identify the solutions. And we'll cover some more advanced factorising methods. So when a, the coefficient of x squared, is greater than 1, I've got a great hack there, little trick that we use. It saves you bundles of time and it's actually quite fun. And we will also look at the difference of two squares, which again is a more advanced factorising method, but one that's quite crucial to learn. Then on to completing the square, that's this here. Put the quadratic into completed square form and be able to identify the vertex, the axis of symmetry, and transcribe the graph, which is just move it. And finally, we're finished with the quadratic formula. That's this big thing here. And we'll look at what's under the square root sign, which is the discriminant, which tells us a lot about what our graph will look like. Okay, so the best way to learn all of this is practice questions. We go through a load of questions on each area, break down the theory as we go. So by the end, you should be an absolute master at quadratic equations. Let's get started. Probably the best way to start is, what is a quadratic? Fundamentally, a quadratic is an algebra equation or an expression where the highest order, otherwise known as power, of x is x squared. So we're talking about this. We're talking about the indice. That has to be x squared. Examples of quadratics would be this one, y equals x squared plus 4 equals 0, y equals 6 minus x squared, and then this one, 3x squared. This is our order, our power, otherwise known as an indice or exponent. So what is not a quadratic is something like this, y equals 2x, because there's no squared term. Here, although there is a squared term, there's a cubed term here with this 3. And so that is not a quadratic, that's a cubic. That will not produce a parabola, the U-shaped graph. And then we should also cover the difference between an equation and an expression. So an equation, that has an equal sign. This one here, that's an equation. Whereas an expression does not have an equal sign. So if you notice, exactly the same terms, x squared plus 5x plus 6, but there's no equals 0. And it is quite relevant that we do know the differences between them, because you can get a question which will be asked to either factorise the quadratic expression or form a quadratic expression from a worded question. So let's look at solving quadratics graphically. But before we dive in, let me introduce myself. I'm Sally. I'm a fully qualified teacher and I'm the founder of Learn Page by Page. You will hear from my accent that I am from the UK, but I do also teach a lot of international students, particularly those in the US. So I will cover both curriculums and terminology because we do have some different ones. I have worked in schools, but for the last 10 years, I've specialised in teaching one-to-one, and I also coach homeschool parents. If you find the video helpful, do go ahead and hit the subscribe. That would really help the channel. And if there's anything in particular you'd like me to record, pop a comment below, because I always read the comments and it'd be great to hear from you. Thank you ever so much. So let's dive straight in. When we are asked to solve a quadratic, such as this one, we have x squared plus 5x plus 6 equals 0. When we're being asked to solve this graphically, what we are being tasked to do is to plot a graph which will roughly look like this. And then the value here we're being asked for, the 0, it's actually 0 on the y-axis. So it's here, it's where the origin is. And the values that we're being asked to find is when the graph crosses the x-axis, because that is when y, which is here, is 0. So all that 0 is this value here, which when we go along the x-axis, that is when y is 0, and that's also when y is 0. And the way we'll be asked to usually solve a quadratic graphically this way is we'll be given a question in which we will be asked to draw this graph from a known set of x values. The question would be something roughly like this, where we're being asked to draw the graph of y equals x squared plus 5x plus 6 for values of x between -5 and 1. then we're being asked to write down the values of x where the graph crosses the x-axis. So let's dive straight in, work through this, and I'll explain the theory as we go. First thing we start with is a table of values, and that's just where we have an x here, y here. We put in the x values that the questions asked us, that between -5 and 1, -4, -3, -2, -1, 0 and 1. And now we need to take the equation and substitute for every place there is an x, we need to substitute the x value for each coordinate. So firstly, we'll start with -5, then we'll move on to -4 and all the way through to 1. And the way I do it is wherever there is an x, I will replace that with a bracket and substitute x for the x value in the table of values. So firstly, we would do -5. So there is an x there, so we put -5 there, put the squared on the outside, +5, bracket again, -5, close the bracket, +6. Then we calculate that, and the first one, -5 squared, is -5 multiplied by -5. That gives us a positive value of 25. The next one, we have a +5 multiplied by a -5. Now there is an invisible multiplication sign in between that number and the bracket. So whatever is inside that bracket needs to be multiplied by the whole value, the +5. So a positive multiplied by a negative gives us a negative, and again 5 times 5 is -25. And then at the end the 6 stays the same, so y will equal 25 minus 25 is 0, plus 6 is 6. So you put 6 in there, and then you'll go on to do each one. So if we go on to do -4, wherever there is x, you replace it with a bracket, -4 squared plus 5, then the bracket, -4, close your bracket, plus 6. And that will be y equals -4 squared is 16, +5 multiplied by a -4 gives us -20 plus 6. So here y will equal 16 minus 20 is -4, plus the 6 gives you 2. And then you want to go on and do each number until they're all filled in. -3 was 0, -2 was also 0, -1 was 2, 0 was 6, and 1 was 12. And now we need to go on and draw the graph. So there's all the information that we need. And when we're drawing the graph, take a look at your x values. You need an x-axis that goes from -5 to 1 and a y-axis that goes from 0 up to 12. So whilst we haven't got any actual negative y values there, our graph will go below the x-axis because it does cross x at -3, and so it will just tip below. Mark your graph x and y. We're just roughly sketching this on a hand-drawn graph without a grid, but I do have a grid overlay, so it is a little easier for me. Ideally, we should really be using graph paper. Something like this would be fine, or you could be a little bit more detailed and use something like this. So our first coordinate, x is -5 and y is 6. Along to -5 on the x-axis, up to 6 on the y-axis. Our first coordinate is there. Next we have -4 and 2. -4 is here, +2 is here, so we'd be looking just about there. And then our next coordinate is -3 and 0. That's on the x-axis, there's -3, that's 0. And then -2 and 0. Then we have -1 and 2, 0 and 6. And the last one I'm not going to worry about too much because I didn't draw the y-axis up to 12. You see the last one was 1 and 12. I've taken the graph up there and it wasn't really necessary. Now we have to draw the graph. So a quadratic graph is a parabola, and that is a U or an N. If x squared is positive, then it's a U shape. But if x squared is negative, so minus x squared, then your graph will have an N shape. And our equation, x squared was positive, so as you can see, we're going to have a U. Now, when you draw the graph, it needs to be nice and smooth. You're not supposed to join the lines rigidly like this. You wouldn't get the mark for doing that. What you're supposed to do is draw a nice smooth graph going up and through like that. Let's do that. And there we are. It's not perfect, it's a bit jiggery, but I am drawing on a tablet, so it's not as easy as if it is with a pencil. With a pencil or with a pen in an exam, move your paper, let your side of your palm sweep, and try and draw a nice smooth graph. But that would be fine. The one thing though I will say is you see down the bottom here where we had the graph cross the x-axis here and here, do not join up those 2 points in a straight line. You need to go a little bit lower in a curve and go back up, because there will be a value down here for which is your turning point, which is actually below when x is -3 and x is -2. So anyway, back to what the question asked us, and if you remember, we go back and look at it, we're being asked to write down the values of x where the graph crosses the x-axis. And so back to the graph, we saw our graph crosses here when x was -3 and here when x was -2. So you would go ahead and say x equals -3 and x equals -2. So before we go into solving quadratics by factorising, we should probably cover how to multiply out brackets, how to expand brackets. The method I use is the FOIL method. If you know this, then do skip forward, but you need to be good at this or understand how to multiply out brackets before you move on to factorising. So here we have a pair of double brackets, or I don't know, if you're in the States, you probably call them parentheses, don't you? Anyway, in the UK, we call them brackets. So you have a pair of double brackets. Now in between these brackets, there is an invisible multiplication sign. I always use the multiplication sign. I don't tend to use the central dot because you see my x's are very different. So you won't get my multiplication signs muddled up with my x's. But if you use the central dot, then you go ahead and use what you're comfortable with. And so what this is asking us to do is to multiply everything in the first bracket by everything in the second bracket. And as I said, we use the FOIL method. So FOIL, the F stands for first, O for outside, the I for inside, and then the L for last. So to begin with, we do the first, and that is this letter here. We're going to multiply this term in this bracket by the first in this bracket. So that's number 1. That's your first. So x times x, that gives you x squared. Next, we do the outsides. So that's this one multiplied by this one here, that +3. And make sure you do focus on the sign. Whilst it's not tricky in this one because we've only got positive signs, when we have a negative, it can be a little trickier. And that's number 2, and that's our outside. And x times +3 gives us +3x. Next, we're going to do the insides, and that's this term here multiplied by this one here. We have +4 multiplied by x. That's our inside, and that gives us +4x. Then lastly, we do the last, and that is this last one multiplied by this last one here. And that's a +4 multiplied by a +3, which gives us +12. And now we need to simplify. And by simplifying, I mean we're going to collect terms which are like each other. The terms that we have in this expression, the first is known as a squared term. The 2 middle ones are letter terms. And then the last one is a number term. And when we're adding or subtracting algebra terms, we can only add and subtract terms that are like each other. So a squared term cannot be combined with a letter term, and the number the same. You can't combine that with any of these terms. So the only terms which are like each other that can be collected, they can be simplified, is this +3x and that +4x there. So you would rewrite this expression as x squared plus 3x plus 4x gives us 7x plus the 12. Let's practice a couple more. I've brought the process over, so let's start with the first. Now, to begin with, you'll be doing these arches, but once you get comfortable with it, you don't have to worry about that. So that's the first one, and that is x times x. That gives us x squared. Then the second, which is the outside, that gives you +7x. Now we'll be dealing with a negative. So this -3 multiplied by x, that gives us minus 3x. And then the last is negative 3 multiplied by positive 7 gives you negative 21. Then we go ahead and collect the like terms. This 7x and this 3x we can combine. So we have 7 minus 3 gives us 4x. So we rewrite the whole expression with x squared. 7x minus 3x is positive 4x minus 21. And this one, you'll notice I've done it equal to 0. And that is because when you factorize a quadratic equation, so what you'll be doing is you will be taking something like this and you will be putting it back into double brackets. When you do factorize it and put it in double brackets, because it's an equation, it will have an equal sign and likely you will have a 0 here, or you might have y, but 0 and y, it's the same thing. We'll come into that in more detail in a minute. But for now, start with the first. That was x times x. That gave you x squared. And then you have x times negative 9, gave you minus 9x. Negative 4 multiplied by x is minus 4x. And lastly, negative 4 multiplied by negative 9. Do the signs first. A minus times a minus is a plus. And that gives you positive 36. Still equaling 0. We must make sure that we always write equals 0. A mistake that a lot of students do make, and that's forgetting to put equals 0. Now we need to collect our like terms. The x squared stays the same. Negative 9x minus 4x gives us negative 13x plus 36 equals 0. So in the case of a quadratic equation, if you have factorized and you need to check whether or not you got it correct, you have the original equation, this is how you would do it. And one thing, I don't know if you've noticed, looks a little bit like a crab or a lobster claw. Now, sometimes you might have a situation where you have to multiply out or factorize and get a single bracket. And that is when you don't have a number term. So in the previous ones, see this one here, we had x squared minus 13x plus 36. Well, the 36 was our number term. If we don't have a number term, then we would just have a single bracket. And the way you multiply them is the same thing. There's an invisible multiplication sign in between the x and the bracket. So this is telling us we have to multiply everything in this bracket by x. So that's x multiplied by x. That gives us x squared. And then x multiplied by positive 3. That gives us positive 3x. And then if you have this one, which is negative x, you guessed it, we have the same rule. Multiply everything in the bracket by negative x. And so you have negative x multiplied by 6. That will give you minus 6x. And negative x multiplied by negative x will give you positive x squared. And then switch that around and present my answer as x squared minus 6x. Now we're going to move on to solving quadratics by factorising, or otherwise known as factoring. In the UK, we tend to call it factorising, but I am aware, particularly in the US, you call it something different. Let me know in the comments if you call it anything different in Canada or Australia or any other English-speaking nations. Be interesting to know. So what does it mean to factorise a quadratic? We're looking for factors. Factors are numbers that divide into something. So what we're actually looking for are the factors of the number term. And so if I move this down, we are looking for two numbers that will multiply to make the number term, which is positive 6, and they need to add to make the letter term, which is the positive 5. This, in a quadratic, this is known as the squared term, this is the letter term, and that's the number term. So we're looking for two numbers that multiply to make positive 6. And I always say focus on the factors rather than this, because once you found the factors, you can then confirm that you've got the right numbers. Take your working out over to the right and think of the factors of 6 and write them down. We look at 1 times 6, then we go to the letter term and we say, does 1 and 6 add to make positive 5? And it doesn't. So pop a line through that and move on to the next pair of factors. And obviously we're working with the factors of 6, so I expect most of you can see that by now it's 2 times 3. And do they add to make positive 5? Yes, they do. So there are two numbers. And then what we do is we go ahead and we open up a pair of double brackets. we still make sure it equals 0 because all we're actually doing here is rewriting this in factor form. So we still actually have exactly the same equation, we've just written it slightly differently. And then because we've only got an x squared, we start both brackets with x. Luckily we haven't got a negative, so we can put a plus in both brackets, so we end up with x plus, and we have positive 2 and a positive 3. So what are our solutions? Well, if we remember from our graph work, we know we're looking for the values of where the quadratic crosses the x-axis. So it was this x value here and this x value here, because that's when y is 0. Remember, that is just y. And where y is 0 is when this bracket and this bracket equals 0. So if you take a look here, we have x plus 2. Well, what could we do to make that bracket 0? And that would be this x value would need to be negative 2, because negative 2 plus 2 would equal 0. And so if this bracket is 0, because this bracket is next to this bracket, and there's an invisible multiplication sign there, that would mean if this bracket is 0, then multiply that by this bracket, the answer would be 0. So we say x equals negative 2. A quicker way of figuring it out is you just look at this value. So you look at the 2 and you just reverse the sign, the opposite sign. So for this one, rather than having to go all through that, we can see that if x was negative 3, that bracket would be 0. So we write and x equals negative 3. And that's your solution. Let's try a couple more. And this one we have x squared plus 16x minus 36 equals 0. We've been given a clue where we're being asked to solve by factorising. We don't always get that clue. Most of the time they will just say solve, particularly in an exam. So let's go ahead and work through the process. So we need to find two numbers that multiply to make the negative 36 and add to make positive 16. And rather than work through them in our head, let's just jot them down to the side. So we have 1 times 36, that makes 36, but won't add to make 16. You see we have a negative sign here and a positive, so we do know that one of our numbers is definitely going to be a negative, but I don't tend to worry about that straight away, not until I get closer to working out if the two numbers do add up to make positive 16. Now let's try the next pair of factors, which is 2 times 18. And I'm liking that. Yep, I can see those two adding together to make positive 16. So what are the signs? Well, as it's a positive 16, the greater value of 18 has to be the positive number. So that would be negative 2 multiplied by positive 18. And now we open up our pair of double brackets. Still make sure we put that to 0 because we've just rewritten the original quadratic in a factored form. We can start each bracket with an x. Here we go. X minus 2 and x plus 18. And then our solutions are these values, but with the sign reversed. So we have x equals positive 2, because that's a negative 2 there, and x equals negative 18. And that graph, we can see it crosses the x-axis at positive 2 and negative 18. But if we look at the number term, this is the y-intercept. This is where it crosses the y-axis. So it crosses right down at negative 36. And if I was to roughly sketch it, probably going to be like that. So that's x, that's y. It's gone through negative 18 there, positive 2 there, and this is negative 36. Okay, now let's try this one. Here, as you see, we're just being told to solve. We're not given any clue of what technique to use. So easiest of all is factorising. And we're going to go ahead and look at two numbers that multiply to make 72 and add to make negative 17. So we're looking for two negatives because the number term has a positive sign and we have a negative here. So let's work out the factors of 72. Firstly, 1 times 72, no way do they add to make negative 17. Then we have 2 times 36, again, they're no good. 3 times 24, we're getting closer. We know they're both going to be a negative, and so that would be negative 27, so they're no good. Next, 4 times 18, again, no. The only combination they would make would be 14 or 22. It can't be that. 5s don't go into 72. 6 would be 12, again, no. 7s, no. 8s, there it is. 8 times 9, so we have negative 8 and a negative 9. They multiply to make positive 72 and they add to make negative 17. You see the value of working this out on the side. I mean, it was obvious. We knew it wouldn't be 1 times 72 or 2 times 36. But rather than sat in an exam, freezing, thinking of all your combinations, if you just get your combinations down and then you know as soon as you get to it what you're working towards. Or if your mental maths is quite quick and you can see straight away it's negative 8 and negative 9, just pop them straight in the brackets. So here we're opening a pair of double brackets, equals 0, and we have an x minus 8, x minus 9, and our answer is x equals positive 8 because we reverse the sign, and x equals 9. So when factorising, where the coefficient of x squared is greater than 1, so this number here, we have a few combinations. So it's not as easy as it was before, where we just look for 2 numbers and multiply to make the number term and add to make the letter term. We will use a slightly different method. So you start off with taking the coefficient of x squared, the 6, and you're going to multiply it by the number term here, which is negative 22. So we take that 6 and multiply it by negative 22, and that is 6 multiplied by 22, and that would give you negative 132, and that's your new number term. So rewrite the quadratic without the coefficient of x squared. So you do x squared, instead of negative 22 you do negative 132, and now what we're going to be looking for is the same as before. We're going to be looking for 2 numbers that multiply to make negative 132, but they have to add to make a positive 1, and the numbers are definitely going to be quite close, aren't they? So if you think your 12 times tables, 12 12s are 144, so 11 times 12, that equals 132, and we know we're dealing with 2 numbers that add to make a positive 1, so that means that our 12 is the positive value because it's greater, and 11 is the negative value. So you go ahead and open up a pair of double brackets, and then you start each bracket this time with 6x. So you go 6x in the first one, 6x in the second one, and then we're going to put in a negative 11 and a positive 12. For the first one, negative 11, and the second bracket, positive 12. Now we go ahead and simplify these brackets. So we're looking if each term shares a common factor. In the first one, we have 6x and negative 11. You can't simplify that. And if we go on to the second bracket, yes, 6x and positive 12 both share a common factor of 6. So you divide each term by 6, and rewrite the bracket, you end up with 6x minus 11 in the first bracket. The second bracket, 6 divided by 6 is 1, so that just becomes x, and 12 divided by 6 is 2, so this bracket is x plus 2. Now that equals 0, and to go ahead and find your solutions, you take the coefficient of the x in the first bracket, you're going to take this and you're going to make it the denominator of the number here. So you'll take the 6 and it will go down there and it will go over there, and that means x equals 11 over 6, which is actually 1 5/6, and it's positive because it was negative there. And our second solution, x equals negative 2. And let's try another one. So we take the coefficient of x squared and we're going to multiply it by the number term, so that's 12 multiplied by negative 5, that gives us negative 60. That's our new number term. rewrite the quadratic with the new number term. We're looking for two numbers that multiply to make -60 but add to make +4. So I'm thinking probably 6 times 10. That gives us 60, and if that's a -6, they will add to make +4. Perfect. Open up a pair of double brackets. Start each bracket with 12x, then we put -6 in one and a +10 in the other, and then we need to simplify each one by looking for a common factor. We have a common factor of 6 in the first one. In the second one, highest common factor is actually 2, so divide this one by 6 and this one by 2, and that will give us our new brackets of 12 divided by 6. That gives us 2, so we have 2x minus 6 divided by 6 is 1. Our second bracket, 12 divided by 2 gives us 6x, and then 10 divided by 2 is 5. Now we put that equal to 0, and we can go ahead and say our solutions are x equals, and we would take that 2 down, that would become the denominator, so that would be +1/2, and x equals, this goes under there, and that becomes -5/6. And here is a special kind of factorising method known as the difference of two squares. So some quadratics will have no letter term, they will have no middle term, and when you have one like this where there is a negative sign in the middle and the number here is actually a square number, there's a special method to factorising this, and it's known as the difference of two squares. So we go about factorising this in exactly the same method, but we only have to look for two numbers that multiply to make -4, and they have to be the same numbers. And so +2 multiplied by a -2, that will give us -4. So our double brackets, we go about it the same way. You open up a pair of double brackets to prove this, and there's x at the beginning of both, and then one is -2 and the other one is a +2. And when you multiply out these, you will actually lose the letter term. Let's see how that happens. So we use the FOIL method. X times x gives us x², x multiplied by +2 plus 2x, and -2 multiplied by x is -2x, and lastly negative by a positive, there's our -4. And when we go ahead and collect our like terms, you can see you've got a +2x minus 2x, that becomes 0, and so it eliminates the middle term. As you can see, that is exactly the same as that. So quite often you could get a question which will have a squared term there, your x² minus another squared term. So it could be 49, that would be -7 and a +7. They would be your numbers. You could even get something like this, 16x² minus 64. So not only have you got a square number here in the 64, you've also got a square number at the beginning. Therefore, you would have a pair of double brackets. And if you take the square root of 16, both brackets will begin with a 4x. And then the square root of 64 is 8. So you have a -8 and a +8. If you're doing any maths exams, do keep a lookout for these because it's quite often slipped in a question paper. Particularly GCSE, they will expect you to know something like this. And now we move on to our third method, and that is completing the square. And what this means is when we complete the square of a quadratic expression, so this would be the general form of x²+bx+c, it means we will be putting it in the form of x plus a new value p plus q. So here are the stages for completing the square. Firstly, we write out the bracket of x plus b divided by 2, and b is our coefficient of the letter term, which we divide by 2. We then square that whole bracket. Once we've done that, we'll look at that bracket and then we will figure out what we need to add or subtract to get the original expression. And you see here, I'm working with quadratic expressions rather than quadratic equations. When we're completing the square, there are quite a few videos on YouTube that will show you how to use completing the square to solve a quadratic equation. And whilst we will move on to that, right now we're going to work on how we put a quadratic expression in completed square form. And that's quite important, particularly if you want to see the turning point or to be able to move the actual graph, to transform the graph. So let's work through a few example questions, and it'll become easier as we work through each one. We need to write x² plus 6x minus 5 in completed square form. And if we remember, the general form was x² plus bx plus c. So b equals 6, and that means b divided by 2 equals 3. And so our bracket will be x plus 3 squared. And then if we were to expand this bracket, that would give us x squared plus 6x plus 9. And if you look at our original expression, we wanted -5 and we have +9. So what do we have to do to make +9 into -5? We have to subtract 14. So that expression there is now written in completed square form. We go on and try a few more. We have x² plus 2x plus 6. I've written the form there again. b equals 2. So b divided by 2 equals 1. Open up the bracket. X plus 1 squared will give us x squared plus the 2x that we want, but 1 times 1 is 1. So at the moment we've got +1, but we want a +6. So what do we need to add on to this to make it +6? And that is 5. Let's do another. X squared plus 8x plus 81. b equals 8. So b divided by 2 equals 8 divided by 2, which equals 4. And that means x plus 4 squared, and that will give us x squared plus 8x plus 16. We wanted +81. We have +16, so we need to add on 65. Here we've got a negative value, so we've got an x squared minus 12x plus 100. And our general form was x squared plus bx plus c. So b equals -12. That means b divided by 2 equals -6. So our bracket will be x minus 6 squared, and those brackets expanded will give us x squared minus the 12x that we want, and a -6 multiplied by a -6 is +36. So to make the +100, we need to add 64. Now they all look relatively simple so far, but as with most maths, they do get a little trickier, especially when we deal with an odd coefficient of x. So when we deal with an odd b value. I'll give you an example. If we have x squared minus 5x plus 20, you can probably see that when we divide -5 by 2, we're going to get a fraction, which can be a bit of a pain, but as long as your fraction skills are good. If you are slightly wobbly on your fraction skills, I have got another video on fractions and I will link it at the end. It covers everything to do with fractions in 5 minutes, so that you might find that really helpful, particularly for completing the square. So here we have b equals -5, and so b divided by 2 equals -5 over 2, and leave it as a fraction. That's the one thing with completing the square. You can end up coming across quite a lot of fractions, and it's best just to leave everything in fraction form. This gives us x minus 5 over 2 squared, and if we expand those brackets, we have x squared minus 5x, and then positive, because a negative multiplied with negative is a positive, and 5 times 5 numerators is 25, 2 times 2 for the denominators is 4. Now the way I do this is if I take a look at what I originally wanted, a positive 20. We need to figure out what we need to add to 25 over 4 to get 20. And the best way to do that is to change 20 into fractional form by putting it over 1, and then we're going to make the denominator 4. So to make the denominator 4, multiply the bottom by 4 and the top by 4. So that means 20 over 1 becomes 80 over 4. And then we need to subtract the 25 over 4, and that gives us 55 over 4. And that's what we need to add to complete the square. Now we're going to go on to actually use completing the square to solve quadratic equations. We have the quadratic equation here, x² minus 4x plus 1 equals 0. First step, we put it in completed square form. And so we have b equals -4. b divided by 2 gives us -2. So the bracket is x minus 2 squared. That would be x² minus 4x plus 4. We wanted plus 1, so we have to subtract 3. So we subtract 3 and that equals 0. And now we just go ahead and solve like a normal equation where we want x on one side and numbers on the other. The first thing we're going to do is we're going to move this -3 over to this side, and being a negative we need to turn it into a positive, so we're going to add 3 to both sides. That gives us x minus 2 squared equals 3. Next thing, we want to remove the squared term, so we're going to take the square root of both sides. Now I always write my operations down the side here. Couple of reasons. I like to be able to look over and see what I've done, but more importantly, if we're doing this in an exam, it's good for the examiner to see the stages that we've used, because there could always be a mark, a credit for that. I find it's always worth showing each stage of your working out. Good habit to preserve. So when we take the square root of this, that loses the squared term and we're just left with x minus 2. And on this side, the square root of 3, that will give us a positive or a negative root 3. And this part is really important, because if we take the square root of 4, for example, that equals 2, because 2 times 2 is 4. But it also equals -2, because -2 multiplied by -2 equals a positive 4. So whenever you take the square root of anything, your answer is always going to be a positive or a negative value. And the way you present in completed square form is you just leave it like this. Now we need to move this -2. We'll do that, we're going to add 2 to both sides, and that will result in x equaling 2 plus or minus root 3. And you can either leave your answer like that or write it out as 2 separate terms. So x equals 2 plus root 3 and x equals 2 minus root 3. If you ask to present your answer as the exact solution, then you leave it in surd form. This is a surd. So root 3 is a surd, and thus it's an exact value. Or you may be asked to present your answer to decimal places, and that means you will put this into the calculator with the requested answer. And here's another one. We're being told to find exact solutions by completing the square. So b is -7. b divided by 2 equals -7 over 2. We leave it as a fraction. Then we have x minus 7 over 2, close bracket, squared, multiplying out that bracket, that gives us 49 over 4, and we wanted 9, which is actually 36 over 4. So 9 is 36 over 4. So we've got to subtract the difference, and 49 over 4 minus 36 over 4, that gives us 13 over 4. Subtract 13 over 4, that will equal 0. And now we go ahead and solve. So we add 13 over 4 to both sides. That gives us x minus 7 over 2 squared equals 13 over 4. Square root of both sides. That gives us x minus 7 over 2 equals, now the square root of 13 over 4, I take that over here, is the same as the square root of 13 divided by the square root of 4, and the square root of 4 is 2. So that actually equals 13 over 2. So that means this is actually x minus 7 over 2. So that equals plus or minus root 13 over 2. Then if we add the 7 over 2 to both sides, we get x equals 7 over 2 plus or minus root 13 over 2. And we'll leave that like that, as they wanted the exact solutions anyway. Then before we wrap up, here's a quick look at why we actually use completing the square. It's when a quadratic is in the completed square form of x plus p squared plus q. The q value, which is outside here, that is the y value of the vertex. And the p value, which is inside with the opposite sign, is actually the x value. Now, the vertex is a turning point, so this means we can identify the minimum, the maximum, and the axis of symmetry, but we can also use this to translate, to move a graph. So here's the completed square form. This number here, that would be your y value, and this number with the opposite sign is your x value. Let's look how that works on a graph. If y equals x squared is the original graph, and that's this graph here, so that will have a turning point of 0, 0. Then if we add a outside of our bracket, this will move the graph, translate it a units up. So if a is positive, then that's going to move it up here. If a is negative, it's going to move it down. So that will move it in the y-axis. Whereas if we were to add a number inside the bracket, as here, then this will move, translate a units to the right. So if you notice here, this is negative. So if this is a negative sign, then the turning point, the vertex, is going to move in the positive x direction. If this is positive, this will move in this direction. I'll quickly show you one example. So you could be asked to draw the graph of y equals x plus 4 minus 3. So with that, we have to move the graph -3 in the y direction. So that means we're going to bring it down. So that'll bring it down, say that's -3. And then because we have a positive 4 inside, that means we're going to move 4 in the negative x direction. So that would be roughly here. So our new turning point would be about here, and that moves the whole graph to about there. And so this graph now has the equation of x plus 4 squared minus 3. And let's look at solving quadratics using the formula. When we solve quadratics using the formula, we work off of the general form, which is ax² plus bx plus c equals 0. And the formula is x equals negative b, so you use the coefficient of the letter term here, plus or minus the square root of b squared, that's the coefficient of x, minus 4 multiplied by a, which is the coefficient of x squared, multiplied by c, the constant term, all divided by 2 multiplied by the coefficient of x squared. And it's useful to know, it's not necessary, we won't go into great detail here, but it's useful to know that the actual formula is derived from completing the square of the general form. And whilst we don't need to go into the exact process of that, what is more interesting is this part of the formula, which is called the discriminant. And what the discriminant can actually tell us is if the quadratic graph crosses the x-axis once, twice, not at all, and even if the solutions will have whole numbers such as integers or fractions. And here we are, I've jotted down the theory for you. So if b squared minus 4ac is a perfect square, then the equation will have solutions which are integers or fractions. If b squared minus 4ac is greater than 0, then the equation will have 2 roots. Remember, roots are just 0. And if b squared minus 4ac is less than 0, there will actually be no roots. So the graph won't cross the x-axis. And if b squared minus 4ac equals 0, there is 1 root. So it would just touch the x-axis. Now let's work through some questions on solving quadratics with the formula. Here is the kind of question you could get. We're being asked to solve the equation x squared minus 5x plus 3 equals 0, giving your answer to 2 decimal places. If you get that in an exam, you've not been asked to solve using a completed square form, and you can't factorise this quadratic, so you will go ahead and use the formula. First of all, let's write out the general form, and then we'll write what each coefficient is. So we have a equals 1, b equals -5, c equals positive 3. Now we write out the formula. We have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and then substitute your values into the formula. So we have negative sign first, and then wherever the letter is, we replace with a bracket and put in our values. We have minus b, so we're going to put a minus 5, close our brackets, plus or minus the square root of b squared, so we pop a bracket there, that's minus 5, close your bracket, squared, minus 4 multiplied by a, which is 1, multiplied by c, which is 3, all over 2 bracket a, which is 1. Remember, wherever you've put a bracket, so here, 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 is actually an invisible multiplication sign in between those, in between that, and in between that. I know a lot of you might be used to using the central dot, particularly in the States, for multiplication, but still I'm going to stick with the multiplication sign because I tend to do my x's like that, so you won't get confused if I use a multiplication sign with my algebra x's. And then let's go ahead and solve this. So we have a negative multiplied by negative 5. That gives us a positive 5, plus or minus the square root of negative 5 squared. That's 25. And then we have negative 4 times 1. That gives us negative 4 times 3. That would give us negative 12. All over 2 times 1 is 2. So we can see from this that the discriminant is 25 minus 12. That's going to be 13. And as that's greater than 0, our solution will have 2 roots. So that's this here. If b squared minus 4ac is greater than 0, then the equation has 2 roots. So it has 2 zeros. It will cross the x-axis twice. And then that goes to 5 plus or minus root 13 all over 2. And they want our answers to 2 decimal places. So x equals 5 plus root 13 over 2, or x equals 5 minus root 13 over 2. And that means x equals, and pop that in the calculator, and there we are, x equals 0.70, or x equals 4.30 to 2 decimal places. And then sometimes you could be asked to show that the equation has no real solutions. Here's an example question. We have 2x squared plus 2x plus 5 equals 0. So what this is asking us is, when this equation is graphed, will it cross the x-axis? It doesn't mean that the graph can't be plotted, because this graph can actually be plotted, but it wants us to show that by using the formula that it has no roots. It doesn't cross the x-axis, and that is when y is 0, which this is y. So write out the general form again. Once you've been doing these for a while, you don't always have to write out the formula, but for now I'm going to write it out each stage just so it keeps it fresh in our mind. There it is, minus b plus or minus square root of b squared minus 4ac all over 2a. And then we have a equals 2, b equals also 2, and c equals 5. Plug our values in, minus 2 plus or minus. We have b squared, so pop a bracket there, squared minus 4, bracket the a, which is 2, and bracket the c, which is 5, all over 2 multiplied by a, which is 2. Take this up there, we have negative 2 plus or minus the square root of, now 2 squared is 4, minus 4 times negative 4 times 2 gives us negative 8, and then negative 8 times 5 is negative 14. So there we are, we can already see it. The discriminant is going to be negative 36, so that would mean we can't go any further. We'll carry on for now until we have to stop. 2 times 2 is 4. Don't forget your equal sign. And then we have negative 2 plus or minus square root of negative 36. We won't be able to go any further with that. So if we finish that, that's 4, and that stops us because we can't do the square root of a negative number. So if you put negative 36 in the calculator, it's just going to scream at you. It's going to come back as undefined because you can't have a square root of a negative number. And so that clearly shows that the equation has no real solutions. And that should cover everything about quadratic equations. I hope that all helped. What I would advise is rewatch the video, go back from the beginning, pause at each stage, skip forward to the areas which you struggle with, rewatch, try and do the questions yourself, make any notes, and then just practice, practice, practice. And you usually find that after you can do about 20 questions in each area, so if you can do 20 on factorising, 20 on the formula, 20 on completing the square, you usually then will have the skills to be able to do them perfectly in an exam. If the video helped, go ahead and hit the thumbs up, subscribe. It would be lovely to stay in touch. And if there's any other video you would like in particular, please do leave a comment below. I always read the comments, and I'm building up a library of content at the moment, and I'm more than happy to do something sooner than I had it planned in my schedule. And thank you, and I'll see you in the next one. Take care. Bye bye.